And the winter of 2026, Montreal's Olympic Stadium looked strangely familiar. The white roof was gone. The center of the building was open to the sky. Around the opening stood the same concrete ribs that television cameras had shown 50 years earlier, when athletes entered this stadium for the 1976 Olympics. Back then, the missing roof was evidence of a deadline the builders had not met. This time, crews had removed it on purpose. They took down 42,019 square meters of fabric. They dismantled 1,332 tons of steel and pulled out more than 22 kilometers of cable. Beneath the field, workers poured over 1,700 cubic meters of concrete just to protect the floor from the machines that would work above it. Quebec has committed 870 million Canadian dollars to put a roof back. Not the roof the architect promised, not the roof that finally arrived 11 years after the Olympics, not the roof that replaced that one and split open during preparations for an auto show. This will be a third answer to the same problem. The new structure is supposed to reopen in 2028. It will be rigid and permanent. Crews will assemble it near ground level, lift it more than 60 meters, and connect it to a stadium whose load path was designed around a very different idea. That idea was simple enough to describe. Montreal would build an Olympic stadium with a roof that could disappear. It was much harder to make real. For half a century, the roof has controlled what this building can do, when it can open, and how much public money must follow it. The stadium has hosted baseball, football, soccer, concerts, trade shows, and more than 66 million visits. It is not an abandoned ruin, but it is a building whose most famous moving part never became dependable. To understand why Quebec is spending almost another $1 billion, we have to begin before the first concrete rib rose from the ground. We have to begin with a mayor who believed deadlines could be commanded, an architect who designed buildings like sculptures, and a roof that depended on a tower which did not yet exist. Jean Drapeau wanted the 1976 Olympics to announce Montreal as a modern world city. He chose the French architect Roger Talibert, whose sports buildings used sweeping concrete forms instead of ordinary columns and boxes. Talibert did not draw a conventional stadium with a lid placed on top. He drew one system. 38 immense concrete brackets would curve inward around an elliptical bowl. They would support the fixed edge of the roof and the upper structure of the stadium. Beside them, a mast would lean over the site at 45 degrees. At its full height, the tower would rise 165 meters. The central roof would hang from that mast. Talibert's scheme treated the open center as a suspended membrane. Steel cables would descend from the tower, pick up the fabric at 26 suspension points, and pull it into shape. Edge cables would tie the membrane back to the concrete ring. Winches inside the system would raise and lower the fabric. When the weather was good, the membrane would fold and retreat into the tower. Spectators would see daylight. When rain or cold arrived, the roof would extend across an opening roughly 200 meters long and 140 meters wide. It was not a dome, it was closer to a tension saddle held in the air by a giant leaning crane. That distinction matters. A rigid dome carries compression through solid members. A membrane carries load through tension. Its shape is part of its strength. Pull it evenly and it becomes stable. Let wind, snow, temperature, or one cable change the forces unevenly, and the shape responds everywhere. The roof was also eccentric. Its tower stood on one side rather than directly above the center. The cable lengths and angles were different. A gust did not arrive as a neat, symmetrical laboratory load. Montreal's snow did not settle according to a drawing. None of that made the concept impossible. Cable roofs and fabric structures can cover enormous spaces with very little material. The original engineering description specified 26 suspension points, 17 edge cables, 43 winches, and a nominal opening time of 30 minutes. But the roof, the mast, the concrete ring, and the control machinery had to work as one machine. Montreal started building before that machine was fully resolved. Excavation began in April 1973. The Olympic opening ceremony was a little more than 3 years away. The stadium was made from thousands of precast and pre-stressed concrete pieces. A factory called Shockbeaton was created to mold them. Each bracket arrived as a sequence of heavy segments that had to fit the geometry of the bowl and carry forces back into the foundations. This was slow, exact work inside a political countdown. Construction disputes, labor stoppages, design changes, and rising costs consumed the schedule. By 1975, the province created the Régie des Installations Olympiques and took control of completing the facilities from the city. The date could not move, the design could. The builders concentrated on the parts required to hold the games. They completed enough of the stadium bowl, seating, field, and fixed perimeter cover to receive the public. The mast stopped as a concrete stump. The moving roof remained a future component. On July 17, 1976, 12,000 athletes and officials entered before more than 76,000 spectators. Television carried the ceremony around the world. Above them was an opening. The games could proceed because it did not rain during the opening ceremony. The unfinished tower sat outside the broadcast frame whenever the right camera angle could avoid it. The stadium fulfilled its immediate purpose, but the architecture shown in the model was still incomplete. The cost was no longer incomplete. Olympic Park's own history places the cost of the facilities at 937 million Canadian dollars by October 31st, 1976. Contemporary accounting cited 922 million for the installations at that point, followed by 537 million in post-games completion work and 17.8 million in transferred city debt. That produces a construction and completion scope of about $1.477 billion. Those figures do not contradict each other, they measure different dates and different baskets of cost. They are often collapsed into one dramatic number, which makes the story easier to repeat and harder to understand. The same problem appears whenever somebody says what the Olympics cost. The Games had an operating budget. The city and province built facilities. Borrowing added interest. Completion continued after the athletes left. Dedicated taxes and other financing paid the debt over decades. The stadium became the most visible part of all of it, even when a number covered more than the stadium alone. Montreal still needed the building after 1976. The Expos needed a baseball home. Large exhibitions needed floor space. The city had a concrete bowl designed around a missing mast and roof. Leaving it unfinished would not make the obligation disappear. It would turn the original promise into a permanent whole, so the work continued. In 1985, the Olympic Installations Authority signed a fixed-price contract worth $117.7 million to complete the tower, mast, and roof complex. Workers extended the tower from its 92-meter concrete base with a changing steel structure that reached the final height. The inclined tower became the tallest structure of its kind. It also became the anchor for the roof's cable system. In April 1987, crews raised the Kevlar membrane into place. The Expos played their first game beneath it days later. 11 years after the Olympics, the stadium finally matched the basic silhouette in Taillibert's model. The membrane covered about 20,000 square meters. 26 cables from the mast carried its internal suspension points. 17 edge cables tied it to the perimeter. 43 winches controlled the system. An inner winter membrane could be installed below it to reduce heat loss and condensation. When the roof opened, machinery drew the fabric upward toward a storage space in the tower. It had to fold without trapping or overstressing one area. When it closed, the winches had to return the suspension points to the correct geometry and tension. The first serious warning arrived a little more than a year after installation. In August 1988, a storm with winds around 80 km per hour tore the membrane in two places. One tier was about 40 meters long. Another was about 5. The following month, a 4-meter tier occurred while the roof was being moved. The Olympic Park history attributes that event to human error. In April 1991, strong winds tore the membrane at 3 points. In June, another rupture ran roughly 120 meters. These were not cosmetic pinholes. A tension membrane works because load can travel through an intact surface and cable network. A tier changes that path. The load concentrates at the edge of the damage. Wind can enter the opening, lift the fabric, and drive the rupture farther. Repairing the material did not remove the conditions that made movement risky. In January 1993, the operators abandoned retractability. The roof was fixed in place so it would no longer tear during opening and closing. The machine built to make the stadium special had completed only 75 folding cycles. For the next several years, Montreal had a roof, but it no longer disappeared. The tower still held the cables. The membrane still carried weather. The stadium had paid the complexity cost of a retractable system and lost the retractable result. By 1996, the authority was seeking a replacement. The second roof took a more conservative approach. It would not move. Bird Air supplied a fixed membrane divided into 63 panels and supported on a steel cable grid. The outer material used fiberglass coated with PTFE, commonly called Teflon. This kind of architectural fabric is light, durable, and capable of spanning large openings. The old Kevlar roof came down in May 1998. The new system closed the stadium later that year. Then winter found the load path. On January 18, 1999, a snowstorm was followed by rain. Snow, ice, and water accumulated on the roof. One panel tore. The material above the main hall released its load into the building while crews were preparing the Montreal Auto Show. The show was cancelled. The second roof had failed within months, but not in the same way as the first. There was no folding cycle to blame. The problem was accumulated environmental load on a fixed fabric surface. Montreal receives roughly 2 meters of snow in an average year. Snow does not remain a light, uniform blanket. Wind piles it into drifts. Heat from inside can melt the underside. Water moves toward low points. A cold layer can trap that water or turn it back into ice. Rain adds mass quickly. The roof therefore became an actively managed winter system. Operators watched weather forecasts and measured cable loads. Heating equipment warmed critical areas. Almost 8 kilometers of radiant cable ran through valleys in the roof to help melt snow and ice. Crews used protocols for clearing accumulation and limiting access beneath the membrane. These measures kept the stadium operating, but they changed the meaning of fixed. The roof did not move by design, yet the building still needed people, sensors, heat, inspections, and weather restrictions to keep the surface within safe limits. Small tears accumulated. The Olympic Park's 2023 to 2024 annual report says the summer 2023 inspection found more than 19,500 tears. That figure does not mean 19,500 open holes large enough to see from the field. Many were small defects and repairs in a fabric system approaching the end of its useful life. But each inspection added evidence that the membrane was not a permanent answer. Winter events became difficult to schedule. Organizers could not treat the stadium like an ordinary enclosed arena. A major booking involves trucks, crews, tickets, insurance, and dates that cannot simply slide because snow enters the forecast. The roof was still covering the field. It was no longer giving the building certainty. It is tempting to stop here and call Olympic Stadium a white elephant. That description is too easy. The Expos played there from 1977 until the team left Montreal after the 2004 season. The stadium hosted Grey Cups, soccer crowds, concerts, religious gatherings, trade shows, and the 2015 CONCACAF Champions League final. The Olympic Park says more than 66 million people have attended events in the building. The wider site also changed. The old velodrome became the Biodome. The tower gained an observatory and offices. The sports center continued operating. The metro already served the complex. Montreal did not spend decades maintaining a completely empty shell. The harder question is whether the building's use justified the continuing constraints and public cost. A 50,000-seat enclosed venue can attract events that smaller arenas cannot hold. It can also sit empty for long periods because very few events need that capacity. A roof problem makes that booking gap worse. Promoters need confidence years ahead. Weather restrictions turn a large venue into a seasonal gamble. That is the case Quebec now makes for reconstruction. The government says a dependable roof could increase the annual number of events from about 30 to 100. It forecasts paying visitors rising from 1 million to 2.1 million, gross revenue rising from $23 million to $61 million, and more than $20 million a year in provincial tax receipts. Those are forecasts, not results. They assume the stadium can win events, fill dates, and operate without another roof cycle consuming the gains. They also describe the whole Olympic Park business plan, not a check produced by the roof alone. Still, there is a real economic difference between a building that organizers trust and one they cannot book in winter. The stadium's defenders are not arguing only from nostalgia. They are arguing that Quebec already owns the largest venue, the metro connection, the concrete structure, and the surrounding institutions. A functioning roof might unlock an asset that is expensive to replace. Its critics look at the same history and see sunk cost logic. Every previous round was presented as the work that would finally make the stadium whole. To decide between those views, the roof cannot be separated from the way the building was paid for. Montreal's Olympic debt lasted 30 years. The province created a special Olympic fund. Tobacco taxes became one of the revenue streams used to repay the facilities. Financing costs continued long after construction crews left. The final mortgage payment was made on November 14, 2006. Olympic Park Material describes a $1.5 billion mortgage on the facilities. A 2026 Bank of Canada museum account places total spending connected to the games and debt repayment at $2.7 billion by the time the debt was cleared. Again, those numbers answer different questions. One describes the long-term obligation attached to the facilities. Another includes the wider spending and financing history. Neither should be presented as the price of one roof, but the dates matter. A child born during the opening ceremony could have turned 30 before the final payment. By then, the first roof had been abandoned, the second had already torn, and the Expos had left for Washington. The debt became part of Montreal's Olympic identity. The stadium's circular shape gave it the nickname the Big O. The bill supplied the second name, the Big O. That joke survives because it compresses complicated accounting into one image. It also hides the decisions that came after 1976. The province did not spend $870 million in 2024 because the original builders left an unpaid invoice. It made a new choice about an old asset. That choice had three broad options: keep repairing the existing membrane until operation became impossible, demolish the stadium and decide what should replace it, or remove the roof and technical ring, preserve the concrete bowl and mast, and build a fixed structural system intended to last. Quebec chose the third. The public justification included an estimate that demolition would cost about $2 billion. During legislative questioning, the tourism minister acknowledged discussion around the age of the underlying work. Opposition members said the figure relied on a study from 2003 and demanded newer analysis. They also sought publication of the studies behind the government's economic return claims. The demolition figure should therefore be treated as the government's stated estimate, not an uncontested current bid. Demolition would be unusually difficult. Pre-stressed concrete does not come apart like stacked blocks. The mast leans over the site. The stadium connects to other occupied facilities. Removing it would create its own engineering project, waste stream, cost risk, and years of lost use. But difficulty does not automatically prove that reconstruction is the better investment. That proof now depends on Roof 3. The headline number is 870 million Canadian dollars. The construction contract with the Pomerleau-Canam Consortium is a large part of it, but the two numbers are not identical. Olympic Park explains that the total also includes public planning, development of the technical solution, support from Quebec's infrastructure agency and professional firms, contingencies, risk reserves, and internal project costs. This matters because a contract price and a project budget protect against different things. The contractor can accept a lump sum obligation for defined work. The public owner still carries planning costs, oversight, changes outside that scope, and risks allocated to the owner. A project can stay within its construction contract and still require money elsewhere. The current schedule divides the work into three major stages. First came removal of the bird air membrane and winterization of the open building. Then crews began dismantling the old concrete technical ring and replacing it with steel. The final stage, through 2026 and 2027, fabricates, assembles, lifts, and installs the new roof. Reopening is scheduled for 2028. The stadium must survive the replacement. Removing the old ring changes weight and stiffness around the top of the bowl. Surveyors monitor how the existing concrete responds as pieces disappear. Designers feed those measurements back into fabrication information for the new steel structure. Below, construction activity is stacked over spaces and systems that cannot simply be treated as an empty field. Crews poured the protective slab and modified mechanical and electrical systems. With the stadium exposed to Montreal winter, temporary barriers and heat must maintain minimum conditions in the occupied interior areas. The old roof was light but maintenance heavy. The new roof is rigid and transfers load differently. Its central section combines metal framing and membrane elements. Around the perimeter, translucent glass is intended to bring daylight into a building long criticized for feeling sealed from the city. A new steel technical ring replaces the heavy concrete ring. Most important, it does not retract. The moving promise has been removed from the requirements. The new roof will first exist close to the ground. Building it low gives crews access without turning every connection into high-altitude work. It allows sections to be assembled, surveyed, and checked inside the stadium bowl. When the structure is ready, the project will raise it more than 60 meters to meet the mast and perimeter. That lift will be one of the most consequential movements the roof ever makes. Afterward, the structure is meant to stay there. According to Pomerleau, the mast will carry about 75% of the roof load. The 38 existing concrete brackets will carry the remaining 25%. The new steel ring distributes forces between them. That arrangement keeps Taillarbart's mast structurally relevant without asking it to operate a folding membrane. The tower remains part of the silhouette and part of the load path. The roof gains rigid members that can control geometry under snow and wind. The design does not eliminate maintenance. No roof in Montreal can ignore snow, temperature, drainage, seals, glass, or corrosion. Rigid structures also move under load. Connections fatigue. Water finds details the rendering did not show. What changes is the failure mode. A small tear in a membrane can grow because the surface itself carries tension. A rigid framed roof can route force around local cladding damage, provided the structure and connections have been designed for it. Inspectors can separate the weather skin from the primary load-bearing frame. The new ring also replaces aging concrete at the most complicated interface in the building. Steel lowers weight and can be fabricated to measure geometry. Curved aluminum cladding will echo the old form without pretending the old technical system remains. The translucent perimeter is more than decoration. It creates a visual break between the existing concrete bowl and the new central roof. From inside, daylight will reveal that the roof is a new intervention. That honesty may be its strongest design decision. Roof 1 tried to complete the 1972 promise. Roof 2 tried to keep the suspended fabric idea while removing movement. Roof 3 accepts that the promise itself was the wrong operating requirement. It preserves the stadium by changing what the stadium is allowed to be. In 1976, Montreal opened an unfinished stadium because the deadline mattered more than completion. In 1987, it completed the original silhouette and received a roof that moved only 75 times. In 1998, it replaced that roof with a fixed membrane that failed during its first winter and accumulated more than 19,500 recorded tears by 2023. Now the stadium is open to the sky again. The current project has stripped away the fabric, cables, and technical ring that made the second roof work. It is keeping the concrete bowl and the mast. It is also keeping the public argument that follows this building everywhere. Supporters see an irreplaceable venue with a metro station, a 50,000 seat capacity, and 50 years of cultural use. They see a roof that can restore 100 event days a year and turn an unreliable asset into a working one. Critics see another forecast attached to the same structure. They see an $870 million commitment supported by a demolition comparison whose underlying estimate is old. They remember that each roof arrived with confidence. Both sides are looking at real evidence. The answer will not come from the rendering. It will come after 2028, in winter when snow crosses the city and event organizers decide whether they trust the dates on their calendars. The stadium does not need a roof that performs a trick. It needs one that becomes ordinary. No emergency closure, no weather clause that empties the schedule, no membrane that has to be watched as a single field of tension, no new repayment story that outlives the people who approved it. That is what Quebec is buying for $870 million. Not the missing piece of the 1976 model, but permission to stop chasing it. 50 years after the first opening ceremony, Montreal is trying to finish the stadium by abandoning the part that was never truly finished.